Today we're going to be working on identifying the slope of a linear function or a line from three different representations: a table, a graph, or an equation, a table, a graph, or an equation. So remember that functions can always be written in three different ways. You have a table representation, which always looks like an XY table. It can be written vertically or horizontally. It can be written as a graph or shown as a graph, right? And that would just be on your coordinate plane. So you could have a line like that, and lines are always infinite. They go on infinitely in either direction. Or an equation. So those are the three representations of functions. An equation of a line of a linear function is y is equal to mx plus b. So x and y are going to be your x and y coordinates from your x and y table or your x and y axes. Your m in this equation is going to be your slope, and b is going to be your y-intercept. So we can also think of your slope as your rate of change. I'll just abbreviate that ROC, your rate of change or your average rate of change. And your y-intercept is your initial value or your starting value. Initial or starting value, right? So when x is equal to 0, that's your y-intercept, right? Because when x is equal to 0, that's where your line crosses your y-axis. Okay, or if x was equal to 0, and let's say y was equal to 5, we would say that our b or our y-intercept, our initial value, is 5. So what is slope? Well, slope measures the steepness of a line. Slope measures the steepness of a line, right? How steep is the line and in what direction? So slope can either be positive or negative. So this graph has a positive slope. So if you were, let's say, walking on this incline, right, you would be from left to right, you would be going uphill, right? It would be very difficult. So this has a positive slope. If you had a graph like this, I always make my lines with double arrows, right? And you are walking along this graph from left to right, you would be going downhill. So this would have a negative incline. So this one is positive. This has a negative slope, okay? There are two other types of slopes. So, because obviously everything isn't always going to be slanted, right? We can have a horizontal line and we can have a vertical line. So horizontal line, if you're walking along this line from left to right, there wouldn't be any resistance, right? It wouldn't be an incline, it wouldn't be difficult to go up, and it wouldn't be really easy to go down. So we would say that this has a slope of 0, or m is equal to 0. Your slope m is equal to 0 for a horizontal line, right? You'd just be walking right across. For a vertical line, well, actually, you couldn't walk on this at all. So this has a slope we would call this slope undefined. And actually, this isn't even a function at all. It doesn't pass the vertical line test, because if you were to put a vertical line through this function, it would cross at infinitely many points, right? Because it would cross. A line is made up of infinitely many points. So this, we would say, is undefined. The slope is undefined, right? You couldn't even walk on that. It would just be like trying to walk up a wall, which we can't. So those are the four different types of steepnesses that you can have and how you would represent them just generally in numbers. So now let's take a look at how can we identify the slope of a function if we're given a table, or some points. So there's two different ways that you can find the slope, and it really depends on what way the information or the function is given to you. So the two ways. So you might have heard of this one. You can do rise over run, right? And this is best for graphs, okay? This is best for graphs. Oop, that marker doesn't work. Because it's really finding the vertical distance between 2 points and the horizontal distance between 2 points. So that's easier if you have a graph on a coordinate plane and you can just count your bunny hops up and count your bunny hops over. The other way that you can find points is using an equation. So your slope is equal to, again, your vertical change. So this delta sign is just like a triangle. Your change in y over your change in x. This is your vertical distance, your change in your y values, which are your vertical values, over the change in x, which are your horizontal values, right? Your rise over run, vertical over horizontal. We can write that, if we're given 2 points, as your y2 minus y1, that's the difference between your two vertical distances, over your x2 minus x1, right? So if you're given 2 points, you would just choose 1 point or one ordered pair to be your first value, your second one to be the second value, and you'd have x and y ordered pairs for both. So you can use either rise over run if you have a graph, or you can use this equation if you have points or a table. So let's first take a look at what that looks like if you have a graph, because for me, a graph is easiest. And I always, even if I'm given a table or ordered pairs, I always still just convert it to a graph. I always just draw myself a graph and I do rise over run. It's just the easiest because I'm a visual learner. So let's say I'm given, draw a graph, and let's say I'm given, let's see, 1, 2, 3, 1, 2, 3. Let's say I'm given a graph and I know that it goes through the point 1, 2, and I know that it goes through the point 2, 1. Let's say it just goes through those 2 points, right? So here is our, I should use a ruler. Do I have a ruler around? Nope, I'm just trying to draw this as accurately as I can. Goes through those 2 points. All right, so there's my line, and I have identified these 2 points on my line. Well, I can just do rise over run for this. So between these 2 points, I'm going up how many? Well, I went up 1. And my run, my horizontal distance would be 1, right? So my rise, my vertical distance was 1. That's this one. And my run would also be 1. So my slope m would be 1 over 1, which is 1. And then I would look at my line and I would say, well, does this have a positive slope or a negative slope? And I know that it has a negative slope, so my slope is going to be -1. Let's take a look at another example. Make it a little bit more difficult, right? So let's say we're going 1, 2, 3, 4. Let's say we're counting by, we can still do 1, 2, 3, 4. So let's say we have this point right here, 1, 1, and this point right here, 3, 2. I think that's good. All right, and we have our line that goes between these 2 points. So again, between these 2 points, I would be going, my rise going up, I would go up 1, but I'd be going over 1, 2, 2 bunny hops, right? So my run would be 2. So my rise is 1, and my run, my horizontal distance is 2. So my slope would be rise over run 1 over 2. I'm looking at the slope of my line and I know that it's going to be a positive slope. So my final answer for my slope is just my slope is equal to 1/2, positive 1/2. So now let's say that we are given ordered pairs, right? Say you're given 2 ordered pairs. Matter of fact, we could just use these ordered pairs, right? Say you're given a problem and they tell you that your ordered pairs are 1, 1, and 3, 2. And you want to find the slope between those 2 ordered pairs, right? Or let's say they gave you even more, right? So if we went up another 1 and over another 2, 3, why did I write 5 here? It should be 4 and then 5. So we went up another 1 and over another 2, we would end up at this point, 5, 3. Okay? And you can keep going up and over and up and over and up and over to get all the points on your line. But let's say that you're given a problem and all they give you is the ordered pairs. Well, here you can go back to that equation that I gave you, or you could on your whiteboard, or you could just draw a graph, plot those. You only have to plot 2 of these points. Plot 2 of these points and find the rise and run between them, just like we did here. if you wanted to do this in equation form, you would identify one of these ordered pairs to be your number 1, one of them to be your number 2, right? So this would be your x1, y1, x2, y2. So if we were to put that into our equation that we had written here, right? y2 minus y1 over x2 minus x1, y2 minus y1 over x2 minus x1. Well, our y in our second ordered pair was 2, minus our y in our first ordered pair, which was 1, over our x in our second ordered pair, which was 3, minus our x in our first ordered pair, which was 1. 2 minus 1 is 1, 3 minus 1 is 2. We got the same answer that we did up here, right? Using the same points from the same graph that we had. Okay, so that's how you could use the equation. Again, if I was given ordered pairs, I would just draw myself a graph and I would use rise over run. But if you like equations better and you're pretty good at substituting and solving like this, go ahead and feel free to do something like this. And last but not least, if you are given, let's say, a table. So let's say you're given a table, and I'll give you some different numbers. Let's say you're given a table like this, and let's make it a horizontal table. 3, negative 4, you have the point 1, 1, you have the point, sorry, negative 1, 6, and the point negative 3, 11. So I'm looking at something, so hopefully these do make a line. It says they do. What I would do, again, I would just convert these to ordered pairs. So I would literally just take these and I'd turn them into positive 3, negative 4 as an ordered pair, 1, 1, negative 1, 6, and negative 3, 11. And then I would graph those and I would do my rise over run. Or you could take these and again put them into your equation just like you did before. Which one should I do? I think these aren't too far apart, but I think that because they go from negative 4 to negative 11, I think that the easiest thing for me to do would be to pick 2 points and use my equation, just because drawing this graph would be a little difficult. So I'm going to go ahead and pick 2 points. So this point looks really nice. 1, 1. I like that. And do I have any other points without negative numbers? No, but this one doesn't scare me too much, right? Negative 1, 6. So I'm going to pick these 2 points. I'm going to call this my first point, and I'm going to call this my second point. And I'm just going to put that into my equation. y2 minus y1 over x2 minus x1. So my y coordinate for my second coordinate pair, or my second ordered pair, was 6, minus the y coordinate for my first ordered pair, which was 1, over my x coordinate for my second ordered pair, which was negative 1, minus the x coordinate for my first ordered pair, which was 1. 5 minus 1 is, 6 minus 1 is 5. And negative 1 minus 1 is negative 2. So if you imagine that you're on a number line, you have negative 1. Minus means you're going left. So if you go left 1, you'd end up at negative 2. So our final answer would be negative 5/2. A positive divided by a negative is still a negative, right? Anytime you have 2 different signs in front, a positive and negative, or a negative and a positive, your whole fraction is still negative. So that would be the slope of the linear function that is represented by this table. Again, I would take these table values, turn them into ordered pairs, and I would either graph them or use our equation. And if I'm just given a table, I can always just find my rise over run from a graph. I'm going to pull out this one, right? Just by doing rise over run between any 2 points on a line.